So let's move to the next question then. Yeah, this is now the next question is again an example where maybe we will need some sort of area. Let's see. It's a hint. Okay, let's write this question. This is a very new good question. It's the 6 o'clock question. So let's write. Let me write. Okay, so we have this two people. So we have. Let's write R and S. Okay, so there are R and S. Okay, so R and S are going to arrive at a place. Okay, R and S arrive at a fair. Let me write this question. It's a good question. Arrive at a fair between. You guys can think about this all. Okay, between 12 and 6. Okay. Now here is the condition. R stays for 1 hour. So he arrives, he stays for 1 hour, and he's gone. He vanishes. And then S, there is S. S stays for 2 hours. Okay. Same. Okay. That's the thing. Okay. And their arrival times are all random. Maybe yeah, arrival times are random. So they don't tell each other. Okay. Are at random. Now something is given. Okay. We know that they were at the fair at the same time. Okay. At some point they were at the, yeah. So we know they were at the fair. Let's say if we know this, okay, at some time simultaneously. There was some point of time. So here we are considering that some interval of time. Let me not say some point of time, okay? Some interval of, let me just say some interval of time, not able to think what the consequences will be. Some interval of time simultaneously. We know this, okay? Then find the probability, or let me just write it in words. What is the probability that both were at the fair at 3 p.m. PM is not there, so 3. Let me just make this 0 to 6. Okay, there is a. That's fine. Okay, so this is an interesting. I find this an interesting question. So let's try this. Okay. Be there arrival times 2 is less than R. No, why is 2 less than R? No, I don't. But okay, that's the probability you want. Yeah, that's not given. Yeah, that's the probability. Yeah, right. No. 2 is less than or less than 3 because you know, yeah, it could. I mean, R could stay. Okay, yeah, I get it. Yeah, so R, you're saying R has to arrive before 3. Yeah, if you want this condition, so this condition would imply that yeah, right. Okay, this, and for S, yeah, so obviously, sorry, yeah, that's right. Should arrive before 3, and so should have, and after 1, otherwise, yeah. So this is what we want. This is the probability that we want. But there is an extra. These conditions are not incorrect, but they will not work. They are not all the conditions, right? Like if we forget about this thing, you see, if we forget about this thing, then this will work. R minus 2 is less than S. Is less than R minus 1. So why is this condition? R minus 1 is less than S, is less than R plus 2. So what is this condition for? Huh. Yeah, so that I don't know if it's complete, but that's what it's line to look at. So let's just look at this condition. Okay. Let's just look at this. So let's forget about this right hand side for a minute. Yeah. So this condition is saying, so what is it saying? That yeah, right. S, so the 1 minute. So S arrives after R. That's no, but that's no, yeah. So that's not correct. Yeah, but yeah, but you understand, right? Yeah, it's easy. But let's do this. So why is this in? Oh, 1 minute, 1 minute. Yeah, 1 minute. Let me write. So if S arrives, so 1 second. 1 second, 1 second. So if S arrives after, so let's just not write this first. Let's break it into 2 cases, then we can simply write it. So S arrives after R. So there is a case. So case 1 is if S is bigger than R. So S is arriving after R. So it means that right. So R arrives before S, but R cannot arrive more than 1 hour before S. Okay. So R plus 1 has to be bigger than S, right? No, this is correct. No, no, no. No, this is correct. This is correct. Just think. Yeah. So then you look at case 2, and it's just simple, similar. So in this case, we can just write it like this, maybe. Yeah. Okay. So this is the condition that is given basically. Okay, this is given, and no, it's not. It's not both. It's either of them. Either of them work, right? So you understand? Yeah? I mean, any one of them will work. We don't want both the conditions to hold simultaneously. They cannot hold. Okay. right? I mean, if one of them is satisfied, we have to go okay. Okay, so we're going to take the union of these two conditions. But how do we now calculate these probabilities? Okay, so yes, yes, but then you see it kind of, it looks a little messy, and also again the sample space is not yeah, is not countable. But yeah, the probabilities are still, yeah, are still understood. Okay, but it is best done, I feel, through a picture. Okay, then you don't have to think so much. Okay, um, so how would you draw a picture of this? Okay, so here is just a small thing I will say, and you guys can extrapolate from here. Let's say that I plot the arrival of R here, possible times for R, and then these are the possible times of S. Okay, right. Yes, right. So that's what we have to do. So can we say, I mean, this is just a small exercise. This is good revision maybe. How would you plot this part, case one? Mm-hmm. Yeah, but in this case, it is x plus 1 is equal to y, or yeah, y is equal to x plus 1. Sorry, y is equal to x plus 1. So when x is 0, y is 1. Yeah, right. So it's above, and this should be done because this is what you have to do quickly in the exam. 1 minute. No, but then we have to take the portion below this or above this, below this, right? Yeah. So it, right, right. So that will come. This will be the thing. And in second thing, it will be -2. So what will be the x-intercept? 2, certainly, right? So this will be a little, so it's not symmetric, okay? Not symmetric. Maybe 2 here, or maybe it's whatever. Okay, and yeah, this is over. So let's not shade it. Yeah, so let's not shade it. So yeah, so do you guys see? I mean, I think this is a good problem, right? For us to just see this technique. Yes, so R is from 2 to 3. So yeah, this will be 1, and this will be 1 to 3. So somewhere it will be, I don't know exactly where. And you guys can figure it out, right? Whether it will be completely inside or not. Um, I was expecting it to be a bit more interesting. But yeah, just figure that out. And then basically this area completely inside, right? It looks like that. So that area divided by this area of this region is your answer, right? Because that, yes, you can do it like that, right? Because that is your universe now, because that's a condition. And the favorable part is that pink region, pink square or pink rectangle. Okay, so the final answer would be area of the pink region by the red region. Yeah, so that is because you can look at this, right? So this is S is the Y, S is the Y coordinate. So Y plus 2 is equal to R. Yeah, so you put Y equal to 0, R is equal to 2. Okay. Okay, so this I think is a good problem. So this is what I wanted to do, some different types of things. That's my goal. Okay, so I'm not going to do more problems today. Okay, so let me say that the next problem is fairly says it doesn't involve much probability, the coin flipping thing. So you guys do it. And again, that the other after the one after that is also using areas. It's good. Okay, to somehow model it through areas, then it's good. I don't know the answer. I know because I had these questions. So when I was teaching one guy at that time, I had access to the book, AOPS book. So I had taken screenshot and then I had given to some other people in a mail, and I had that mail. So I didn't forward the mail because yeah, but I just downloaded it. I don't have the solutions or the answers now because that book seems. It's about the angles, but once again, the conditions seem to be continuous, right? So that's why modeling it through area